In the vast expanse of the cosmos, hidden beyond the veil of stars and nebulae, mysteries beckon our curiosity. From the dawn of human consciousness, we have gazed into the infinite, wondering about the celestial enigmas that dance silently above. Even today, in an age of profound scientific discovery, the cosmos continues to guard its deepest secrets, teasing us with puzzles that challenge our greatest minds and technologies. Imagine standing at the threshold of the observable universe, billions upon billions of galaxies spiraling through the dark, each holding billions of suns. Yet, within this astonishing abundance, we find perplexing absences, regions of darkness known as cosmic voids. These voids stretch unimaginably vast distances, tens or even hundreds of millions of light-years across, containing almost nothing at all. Their existence challenges our understanding of cosmic evolution. What force, we wonder, orchestrated such profound emptiness amid an otherwise crowded cosmos? And what about the nature of the universe itself? Are we alone, or is our cosmic address just one among infinite multitudes? The tantalizing possibility of a multiverse captivates astronomers and physicists alike. Perhaps our universe is but one bubble in an endless sea of universes, each with distinct laws of physics. Somewhere out there, could there exist worlds with entirely alien forms of life, thriving under skies illuminated by unfamiliar constellations? Closer to home, yet no less puzzling, is the enigma of dark matter. Invisible, intangible, and yet undeniably influential, dark matter weaves through the very fabric of the universe, shaping galaxies and guiding their motions with an unseen hand. Its gravitational pull reveals its presence, yet all attempts to detect its essence have thus far failed. Could dark matter be an entirely new form of particle? Or does it suggest something profound about the laws of physics that we have yet to understand? Then there's dark energy, the mysterious force responsible for accelerating the expansion of the universe itself. It composes over 2/3 of the cosmos, yet remains profoundly elusive. It pushes galaxies apart, stretching space-time faster and faster, seemingly defying logic. What exactly is dark energy, and how does it alter the ultimate destiny of our universe? Will our cosmos expand forever, growing colder and emptier, or could some unknown phenomenon alter this trajectory, shifting our fate? Even within our own galactic backyard, mysteries linger in plain sight. Black holes, cosmic abysses from which not even light escapes, captivate and terrify us in equal measure. Recent observations of supermassive black holes merging have sent ripples through space-time, gravitational waves that echo the drama unfolding billions of light-years away. Yet the greatest mystery remains hidden behind the event horizon. What happens to matter and energy when they vanish into that gravitational abyss? Could black holes hold clues to understanding the fundamental nature of reality itself? In our endless pursuit of understanding, we have turned our instruments skyward, creating vast arrays of telescopes that peer deeper into space than ever before. The James Webb Space Telescope has revealed galaxies at the very dawn of time, challenging our theories of cosmic evolution and formation. Yet with every answer uncovered, new questions arise, questions that lead us further into the unknown, ever expanding our horizons. Perhaps the greatest cosmic enigma is life itself. Are we alone in the universe? As we scan distant worlds orbiting faraway suns, we detect tantalizing hints, signatures of potential atmospheres, water, and even organic compounds. Yet still, the definitive evidence of extraterrestrial life eludes us. Somewhere among the countless worlds circling distant stars, life may thrive, evolving in forms we cannot yet imagine, gazing back at us across the void with their own curious eyes. Each of these mysteries, dark matter, dark energy, cosmic voids, black holes, and the possibility of extraterrestrial life compels us toward a deeper understanding. Our cosmic journey is one of profound humility and endless fascination, a search for meaning in an indifferent universe. With every step forward, we grow closer to comprehending our place within the infinite tapestry of stars, planets, and galaxies. A cosmic story of which we are only beginning to understand the opening lines. We stand at the precipice of discovery, gazing outward into a universe richer and stranger than we ever imagined. These unsolved enigmas invite us onward, compelling us to venture further, to question deeper, and to dream bigger. Beyond the boundaries of human imagination lies an intricate tapestry woven from stardust and illuminated by cosmic energies that have shaped existence itself. Our curiosity draws us ever further into realms unseen, deeper into mysteries yet unresolved, stretching our understanding of reality beyond every frontier we've known. Consider, for instance, the cosmic symphony of pulsars, dead stars spinning rapidly, emitting precise beams of electromagnetic radiation like celestial lighthouses. These enigmatic beacons pulse with clockwork precision, challenging our grasp of physics with their astounding regularity. Yet occasionally, some pulsars break their rhythm, inexplicably shifting their frequencies. What cosmic phenomenon could disrupt their perfect tempo? What unseen forces act upon these ancient stellar corpses, altering the celestial metronomes we've relied upon for decades? Elsewhere, hidden deep within the heart of our own Milky Way galaxy, lies an enigma known as Sagittarius A*, a supermassive black hole with a mass millions of times greater than our Sun. Its gravitational pull influences entire star systems, yet its innermost workings remain cloaked in secrecy. Recent images have begun to peel back its mysteries, but still, we ask, what truly lies at its core? Could it hide answers about how galaxies themselves are born, grow, and eventually fade into cosmic twilight? Even stranger still is the phenomenon of fast radio bursts, enigmatic signals originating from billions of light years away, lasting only milliseconds, yet carrying more energy than our Sun produces in decades. Their source is utterly unknown, defying explanation even after intense scrutiny. Could they be echoes from catastrophic stellar collisions, the remnants of collapsing neutron stars, or perhaps something even more extraordinary, a message, intentional or accidental, sent by distant civilizations attempting to reach across the cosmic gulf? Then there is the compelling mystery of cosmic inflation, the dramatic expansion of space itself mere moments after the Big Bang. This theory attempts to explain why our universe appears uniform yet holds secrets locked tightly away in the quantum realm. Scientists grapple with tantalizing questions. How could such rapid growth occur? What triggered it? And could there exist signatures of this cosmic infancy imprinted upon the background radiation, subtle whispers awaiting detection through advanced telescopes yet to be built? From time immemorial, humanity has pondered the great cosmic cycle of birth and death. Stellar nurseries, great nebulae like Orion or Carina, cradle newborn stars within luminous clouds of gas and dust, glowing majestically against the darkness. Yet these beautiful formations also conceal mysteries about how planetary systems form, how raw materials coalesce into worlds, and whether the conditions for life might frequently, or rarely, emerge from this celestial chemistry. Amid these cosmic wonders lies the phenomenon known as rogue planets, worlds that drift silently through interstellar space, unbound to any star. Born perhaps from chaotic gravitational interactions, these isolated wanderers intrigue astronomers as potential havens of hidden oceans beneath icy crusts, preserved by geothermal energy and shielded by darkness. Could these solitary worlds harbor life in their lonely journeys through the endless night? We are captivated also by the subtle question of time itself. Einstein's revelations showed us that time is flexible, shaped and warped by mass and motion. Near massive bodies, minutes and seconds flow differently, an astonishing reality confirmed by modern technology. Yet, we still grapple with deeper existential puzzles. What exactly is time beyond our measurements? Is it an emergent property woven into the fabric of space itself, or merely a perceptual illusion created by consciousness attempting to make sense of change? In this era of breathtaking technological achievement, we stand on the threshold of harnessing new methods of cosmic observation, neutrino telescopes, gravitational wave detectors, and enormous arrays of radio dishes spanning continents. With these powerful instruments, we are beginning to listen closely to the subtle whispers of the cosmos, uncovering phenomena previously invisible and inaudible. Yet, as these discoveries unfold, they pose even deeper mysteries, urging us toward new theories, new questions, and new dreams of exploration. Every revelation reveals deeper layers of complexity. Each mystery unraveled opens pathways toward more profound enigmas. We find ourselves engaged in an eternal dialogue with the universe, a dialogue whose words are encoded in cosmic radiation, gravitational vibrations, and electromagnetic pulses. Our science, our art, our culture, indeed, our very humanity is continually shaped by the endless journey of exploring the unknown, propelled by an innate desire to uncover truths hidden within the infinite cosmos. Far beyond the familiar constellations we know so intimately, the universe harbors worlds profoundly alien, exoplanets orbiting distant stars, each telling a unique cosmic tale. Some orbit pulsars bathed in radiation, enduring relentless stellar winds. Others drift serenely within the warm embrace of red dwarf stars, tantalizingly positioned within the delicate balance of habitable zones. Among these strange, distant worlds, we sense the whisper of potential, the promise of discovery waiting patiently within the cosmos' eternal silence. Yet, even as we cast our gaze outward, mysteries closer to home compel our attention. The outer edges of our solar system, far beyond Neptune's orbit, hold secrets yet unexplored. Distant objects like Sedna, Quaoar, and Eris wander in elliptical paths through an icy darkness, their strange orbits hinting at gravitational influences still undiscovered. Could there be a hidden world, Planet 9, lurking at the fringe of our cosmic neighborhood, silently guiding these distant travelers through the deep, cold expanse? And what of the enigmatic interstellar visitors, objects like Oumuamua, whose brief passage through our solar system left astronomers puzzled and intrigued? Neither asteroid nor comet, it defied categorization with its unusual shape and unexplained acceleration. Did it emerge from natural processes unknown to our physics, or might it have originated from civilizations far across the galaxy, remnants of alien technology drifting silently through space, a fleeting visitor reminding us of our profound ignorance? Our exploration of the cosmos also raises intriguing questions about the boundaries of physics itself. Quantum entanglement, particles linked instantaneously across vast cosmic distances, challenges the very foundations of our understanding. Could entangled particles serve as bridges across space-time, hinting at a deeper interconnectedness woven into reality itself? Are there hidden dimensions folded quietly into our universe, invisible yet influential, subtly affecting gravity and quantum mechanics in ways we've barely begun to comprehend? In the fabric of space-time, gravitational waves ripple invisibly, distortions caused by catastrophic cosmic events like colliding neutron stars or merging black holes. Recent detections have confirmed Einstein's century-old prediction. Yet each event observed generates more questions than answers. Could gravitational waves provide insights into the birth of the universe itself? Reverberations echoing faintly from the Big Bang's first moments, carrying with them messages encoded at the dawn of cosmic time? Across the vast expanses of interstellar space, another mysterious phenomenon awaits understanding. Intergalactic magnetic fields, immense structures spanning millions of light-years, subtly influencing the formation and evolution of galaxies. These colossal, invisible webs shape cosmic evolution in ways that remain unclear. How do such magnetic fields form on such vast scales? Could they explain strange cosmic phenomena, guiding cosmic rays or influencing the birth of stars within massive clusters? Even more provocative is the cosmic coincidence that allows our universe to exist in its current form. Fundamental physical constants, the strength of gravity, the mass of electrons, and the precise balance of nuclear forces seem finely tuned to permit galaxies, stars, planets, and ultimately life itself. Was this cosmic lottery mere chance, or is there some deeper principle, a hidden law awaiting discovery, underlying this improbable alignment? Humanity's reach is now extending far beyond Earth, with new missions poised to unlock further mysteries. Robotic explorers venture forth, journeying to worlds such as Europa, Titan, and Enceladus, icy moons harboring deep subsurface oceans, potential sanctuaries for life. Could life exist beneath their frozen crusts, thriving in darkness and isolation, sustained by chemical energy and warmth emanating from their planetary cores? As our technology propels us deeper into space, we find ourselves continually confronting mysteries whose explanations lie tantalizingly beyond our grasp. Solar anomalies such as the unexplained heating of the sun's corona, far hotter than its visible surface, pose puzzles that defy conventional physics. What mysterious mechanisms within our closest star drive this phenomenon? And what can they teach us about stars scattered across the universe? Each discovery prompts fresh wonder, inviting speculation about realms we have scarcely imagined. Perhaps somewhere, in distant corners of space-time, lies the possibility of traversing cosmic distances swiftly, as suggested by theories of warp drives or wormholes, concepts that remain speculative yet enticingly grounded in mathematics. Could future civilizations unlock these possibilities, rewriting the rules of interstellar exploration? We stand now at a crossroads of knowledge, poised on the cusp of answers and yet perpetually humbled by the cosmic unknown. Driven by curiosity and guided by the wonders that shimmer in distant galaxies, our exploration continues, an eternal quest to understand not just the universe, but our own existence within its infinite, mysterious embrace. Across the infinite cosmic landscape, we encounter phenomena that strain even our boldest theories and most imaginative concepts. At scales both immense and infinitesimal, the universe surprises and humbles us, forever reshaping our understanding of reality itself. Deep beneath the surface of space-time lies the mystery of quantum gravity, the enigmatic bridge linking the colossal with the microscopic. General relativity describes vast expanses, galaxies, and black holes, while quantum mechanics illuminates the peculiar realm of atoms and subatomic particles. Yet, when these worlds intersect, paradoxes emerge that puzzle even our greatest minds. Could a unifying theory emerge, finally bridging the cosmic gulf, revealing a deeper fabric from which all reality is woven? Among the strangest phenomena in physics is the holographic principle, a radical idea suggesting our universe might be a projection, encoded upon its boundaries, a cosmic hologram. This profound notion arises from efforts to resolve the paradoxes surrounding black holes and their mysterious event horizons. Could reality itself, as intricate and tangible as it seems, ultimately be reduced to information stored at the edge of spacetime? Such speculation challenges our deepest intuitions about the nature of existence itself. Further complicating our cosmic understanding is the phenomenon of antimatter, an elusive mirror image of ordinary matter that annihilates upon contact. While experiments routinely create antimatter particles, the universe itself is curiously devoid of antimatter. Why does ordinary matter dominate the cosmos, leaving antimatter nearly absent? Understanding this imbalance could hold keys to the deepest questions about how the universe formed and why life itself was permitted to exist. At the edge of observational astronomy, the cosmic microwave background radiation, a faint afterglow of the universe's fiery birth, holds tantalizing clues to the cosmos' earliest moments. Subtle anomalies in its ancient patterns hint at unknown processes at play during the universe's infancy. Could these anomalies indicate interactions with parallel universes or evidence of cosmic strings? Massive, one-dimensional defects theorized to ripple through space, remnants from the early universe? Even our comprehension of space itself may be incomplete. Phenomena such as white holes, hypothetical opposites of black holes, from which matter might burst forth rather than collapse inward, remain purely speculative yet profoundly intriguing. Could white holes, still undiscovered, exist within the universe, serving as portals through space-time, erupting matter and energy from elsewhere? If found, they might radically reshape our understanding of cosmic structure and the balance of mass and energy. Meanwhile, the search for extraterrestrial intelligence continues to push the frontiers of astronomy. Efforts such as SETI meticulously scan the skies for signals, yet profound silence persists. Known as the Fermi paradox, the puzzling absence of observable alien civilizations confronts us with a haunting question: where's everyone? Are we uniquely fortunate, alone in a universe teeming with potential habitats, or do advanced civilizations deliberately remain hidden, leaving only silence as evidence of their existence? Moreover, even our concept of consciousness, of sentience itself, poses cosmic implications. Does consciousness exist elsewhere in forms unimaginable to us, perhaps embedded within stellar plasmas, clouds of cosmic dust, or even vast networks of interstellar radiation? The idea of a cosmos alive with intelligence far beyond biological forms opens fascinating and unsettling possibilities. What hidden awarenesses might observe our fragile blue world from afar, aware of our existence even as we remain oblivious to theirs? The cosmos also confronts us with the enigma of time travel, a fascinating, theoretical consequence embedded in Einstein's equations. Closed time-like curves, loops in space-time where one could potentially revisit the past, raise questions about causality and paradox. If time travel were possible, how might the universe prevent paradoxes, protecting the continuity of reality itself? Could quantum mechanics, through concepts like parallel timelines or multiverse branches, allow such travel without contradiction? As our probes and telescopes reach farther, our instruments sharper, we approach thresholds of discovery that once seemed impossible. Missions like Voyager and New Horizons, now journeying into interstellar space, expand humanity's physical presence beyond our solar system. They carry messages, greetings from Earth, small testaments to our enduring desire for connection amid the void. Yet, how might future civilizations interpret our offerings? Could our tiny spacecraft, drifting silently through the cosmos, someday become enigmas themselves? Mysteries awaiting decipherment by beings yet unborn? Everywhere we look, the universe speaks in whispers, leaving hints and traces of phenomena still unexplained. We find ourselves locked in an eternal cosmic dance, forever observing, forever questioning, driven forward by the relentless mystery that defines our existence. There are forces and phenomena that challenge not only our science but the very limits of our imagination. Cosmic riddles so complex, they blur the line between physics and philosophy. In the heart of distant galaxies, we observe quasars, luminous giants powered by supermassive black holes consuming matter at astonishing rates. These beacons, some brighter than entire galaxies, emit torrents of energy across the cosmos. And yet, their light reaches us from a time when the universe was still young. How could such massive structures form so early in cosmic history? What unknown processes allowed the rapid birth of these ancient giants? And what do they reveal about the architecture of the early universe? We now know the universe is not static but in motion, expanding, evolving, stretching the fabric of spacetime itself. But as we peer deeper into cosmic history, evidence suggests the expansion might not be uniform. Large-scale structures, such as the Great Attractor or the Shapley supercluster, seem to tug at galaxies with unseen influence. These immense gravitational anomalies raise fundamental questions about the homogeneity of the universe. Could there be regions of space far larger than we imagine, exerting forces we barely detect? In some corners of theoretical physics, even the possibility of a cyclical universe has emerged, a cosmos that expands, contracts, and rebirths itself in an endless series of big bangs. If true, what we perceive as a beginning might only be a continuation of a much older rhythm, a heartbeat echoing through time beyond the horizon of our knowledge. What remnants might survive such transitions? Could black holes or gravitational imprints carry information from previous iterations of reality? The nature of vacuum energy, too, is an unsolved mystery. In quantum theory, even empty space is not truly empty. It teems with virtual particles flickering in and out of existence. This energy of the void might be responsible for the accelerated expansion of the universe, but if it were slightly stronger or weaker, the cosmos would have collapsed or flown apart before galaxies could even form. Why does the vacuum possess just the right amount of energy to permit structure, life, and consciousness? There are also ancient relics scattered throughout the universe, globular clusters, star populations older than the galactic disk, and anomalous stars with chemical signatures defying our expectations. These objects might be messengers from an era we barely understand, fossils from a time before the galaxies settled into their spiraled grace. Could some of these stars predate the galaxies they now orbit? Are they fragments of a lost epoch carrying the chemical fingerprints of a different kind of cosmos? Then there is the strange tale of ultra-high energy cosmic rays, particles that arrive at Earth with energies so great they defy known astrophysical processes. They crash into our atmosphere with violent intensity, yet their origins remain unknown. Are they birthed in colliding black holes, or perhaps emitted from exotic phenomena like decaying topological defects in the structure of spacetime? These cosmic messengers challenge us to expand not just our instruments, but our understanding of energy, space, and origin. In some theoretical landscapes, even information itself plays a central role in the evolution of the universe. The idea that the universe processes information almost like a computational system suggests a deeper layer of reality. Could the laws of physics themselves emerge from informational rules, patterns woven into the fabric of existence? If so, then everything from stars to consciousness might be expressions of a universal algorithm unfolding across time in patterns we are only beginning to decipher. And still, we return to the question of the observer. In quantum mechanics, the act of observation influences outcomes, wave functions collapse, probabilities resolve. Could it be that consciousness plays a fundamental role in shaping reality? Some interpretations hint that the universe may not be entirely objective, but partially participatory. Is our awareness merely an emergent product of complex matter, or does it hold a deeper place in the cosmic equation? In every direction we look, whether through the lens of a telescope or the abstractions of mathematics, we are met not with finality but with questions. The cosmos remains an unfinished manuscript written in symbols we are still learning to read. In the silence between galaxies, where matter thins into almost nothing and the darkness stretches unbroken for millions of light years, the universe continues its quiet, cryptic narration. These intergalactic gulfs, where even light takes eons to traverse, are not empty in the truest sense. They hum with relic radiation, whisper with faint neutrino winds, and carry the residual tremors of ancient cosmic events. signals so delicate, yet so profound, that they reach across time to tell stories older than memory. Among the most haunting of these stories is the puzzle of the baryon asymmetry, why there is something rather than nothing. In theory, the Big Bang should have produced equal amounts of matter and antimatter. And yet, our universe is made almost entirely of matter, with antimatter mysteriously missing. What unknown mechanism tipped the scales in favor of existence? Somewhere, deep in the early universe, a symmetry was broken, but how and why? There are also subtle, often overlooked anomalies in the large-scale structure of the universe. Strange alignments in the cosmic microwave background, inexplicable patterns in galaxy distributions, and temperature fluctuations that resist our statistical expectations. These cosmic coincidences hint that something more may be at play, perhaps a previously undiscovered influence from before the inflationary epoch, or echoes from a universe adjacent to ours in a higher dimensional multiverse. Gravitational lensing, a phenomenon predicted by Einstein's general relativity, bends light around massive objects and reveals distant galaxies magnified like cosmic mirages. Yet even here, mysteries persist. Some lenses seem to magnify more than expected, or produce multiple images in strange configurations. These deviations might be the fingerprints of dark matter clumps too small to detect otherwise, or even evidence of new physics subtly altering the way gravity behaves at vast scales. Beyond gravity and light, we explore with neutrinos, ghostly particles that pass through entire planets as if they were smoke. These elusive messengers are born in the hearts of stars, in supernovae, and perhaps even in the decay of primordial particles from the universe's earliest moments. Their strange behavior, oscillating between identities as they travel, suggests mass where there should be none, and a connection to forces that remain hidden from our equations. Could neutrinos be a bridge between the visible universe and an invisible one? Tucked within galaxies are ultra-diffuse galaxies, enormous structures with barely any stars, almost transparent against the black. How such faint giants form remains an open question. Some seem to lack dark matter altogether, while others appear to be entirely governed by it. They challenge our classifications and hint at a broader diversity of galactic evolution than we once believed possible. At the intersection of cosmology and particle physics, we confront the mystery of axions, hypothetical particles so light and shy they've never been seen, yet might account for the missing mass of the universe. If real, they could form vast, invisible halos around galaxies, subtly guiding the motion of stars. Experimental searches push forward, trying to catch these particles in the act of whispering into the magnetic fields of the Earth. And all the while, the arrow of time continues its relentless march from past to future, yet the fundamental laws of physics are, curiously, time-symmetric. Nothing in the equations demands that time move in one direction. So why do we remember the past but not the future? Why does entropy increase, driving the cosmos toward disorder? The thermodynamic arrow remains one of the most subtle and profound mysteries, pointing toward deep truths about the structure of time, causality, and perhaps even consciousness itself. The more we explore, the more we find that certainty is an illusion. Each discovery is not a conclusion, but an invitation to deeper wonder. The cosmos is not a puzzle with a final solution, but a living story, one in which we are both observers and participants, shaped by the very universe we strive to understand. And though the darkness stretches endlessly outward, filled with riddles and silences, it also echoes with the quiet certainty that something extraordinary lies just beyond the limits of what we know. In the ocean of space-time, where galaxies drift like luminous islands and time flows like an unseen current, the universe conceals truths that lie just beyond the veil of understanding. It is a place where the known laws of physics govern with elegance and precision until they don't. And it is in these places, at the edges of theory and the heart of anomaly, that the most profound questions await. One such question emerges from the apparent inconsistency in the measurement of the universe's expansion rate. Two methods, one rooted in observations of the early universe, the other in measurements of nearby galaxies, arrive at different answers for the Hubble constant. This Hubble tension is not merely a numerical discrepancy, it could signal that our standard cosmological model is incomplete. Perhaps some hidden ingredient of the cosmos, something we have yet to conceptualize, is shaping the expansion of space in ways we've failed to grasp. The fabric of space itself may not be as smooth as once believed. On the tiniest of scales, where quantum mechanics dominates, space may seethe with fluctuations, random bursts of energy and particles appearing and vanishing in a chaotic froth. This concept, known as quantum foam, suggests that space-time might be grainy, pixelated, or otherwise fundamentally granular. If so, then everything we perceive as continuous and fluid may be a shimmering illusion, a macroscopic effect of a restless, discrete foundation. Even black holes, long considered the final word in gravitational collapse, are now being reimagined. The information paradox, a conundrum born from the clash between quantum theory and general relativity, questions whether information about matter swallowed by a black hole is truly lost forever. Recent theories propose that black holes might preserve this information on their surface, or subtly leak it through quantum processes. If these ideas hold true, black holes may not be tombs of knowledge, but strange archivists, encoding the history of the matter they consume. At cosmological scales, the cosmic web reveals itself, a vast structure of filaments and nodes, where galaxies cluster like dew along the threads of an invisible scaffold. Simulations have shown how gravity assembles this cosmic lattice from initial fluctuations after the Big Bang. But we still do not fully understand why the universe's structure takes this exact form. What hidden variables shaped the web's design? Could other universes, governed by slightly different laws, produce entirely different cosmic architectures? Our very perception of physical constants, the speed of light, the gravitational constant, the strength of the electromagnetic force, rests on the assumption that they are immutable. But what if they vary across space or time? Some bold hypotheses suggest these constants may have shifted over the history of the universe, subtly influencing the formation of stars, the chemistry of life, and the unfolding of cosmic history. If true, these variations would suggest a dynamic reality far stranger and more malleable than previously imagined. On the frontiers of astrophysics, the possibility of exotic matter emerges, forms of matter not described by the standard model. Strange quark matter, hypothetical stable remnants from the early universe, could linger as tiny but incredibly dense nuggets scattered across space. Some even speculate about mirror matter, a counterpart to all known particles that interacts only through gravity and possibly a hidden mirror force. These ideas, while speculative, open entirely new chapters of inquiry into what the universe is truly made of. Cosmic censorship, a principle once proposed to protect the universe from revealing its most chaotic aspects, posits that singularities, points where gravity becomes infinite, must always be hidden within event horizons. But recent mathematical explorations suggest exceptions may exist. Naked singularities, visible cracks in the cosmic order, where space and time unravel in full view. If these objects exist, they could serve as natural laboratories for testing quantum gravity, exposing the raw heart of the universe's deepest mechanics. We are beginning to ask whether the universe itself might be conscious, or at least capable of processes that resemble awareness on scales and in forms foreign to human experience. Integrated information theory, panpsychism, and other speculative frameworks attempt to bridge the chasm between matter and mind. Could consciousness emerge not as a biological accident, but as a fundamental property of complex systems, galaxies, networks of stars, or even space-time itself? The cosmos, it seems, is not merely a stage upon which life unfolds. It is a dynamic, evolving entity, teeming with structure, fluctuation, and possibility. It does not merely permit our existence, it provokes our imagination. In chasing its mysteries, we are drawn into a conversation billions of years in the making. One in which every photon, every gravitational wave, every unanswered question is a whisper from the depths, urging us not to settle, not to rest, but to keep listening. Amid the distant echo of ancient starlight and the deep gravitational silence of collapsed worlds, the cosmos offers yet more enigmas that blur the boundary between the material and the metaphysical. It is not merely the scale that astonishes, but the layered depth of complexity that unfolds with every deeper look, every finer calculation, every fainter signal received from the abyss. One of the most perplexing phenomena in astrophysics is the apparent alignment of large-scale structures across billions of light years, a strange coherence in the spin of galaxies, or the polarization of light from the cosmic microwave background. These patterns defy expectations of randomness and isotropy, suggesting a hidden architecture beneath the surface of the cosmos. Could the early universe have been shaped by forces beyond our comprehension, imprinting a directional signature that still echoes across space? The concept of time dilation, no longer an abstraction but a measurable reality, adds further depth to the mystery. In the presence of immense gravity or near the speed of light, time stretches and warps. For particles orbiting a black hole, time may slow to a near halt relative to the wider universe. To observers elsewhere, a moment near the event horizon could span centuries. This warping of time raises profound implications not only for physics, but for our philosophical grasp of reality. Is the present universal, or a mosaic of relative experiences layered one upon another like echoes through eternity? Recent observations of primordial black holes, hypothetical remnants from the earliest epochs, pose another riddle. Unlike stellar black holes, these may have formed not from collapsing stars, but from quantum fluctuations in the hot, dense soup of the newborn universe. Some speculate that they might constitute a portion of dark matter, roaming unnoticed through space. Others entertain a more radical notion, that entire universes may be born within these objects, each black hole a seed of a separate cosmos, budding from the death of another. Cosmic strings, once a fringe idea, now linger at the edge of possibility. These hypothetical one-dimensional defects in spacetime, infinitely long yet thinner than an atom, could have formed during the universe's earliest moments. If they exist, they may slice through the cosmos, leaving behind gravitational imprints and warping light in measurable ways. Their discovery would rewrite our understanding of the early universe and suggest a far more dynamic, fragmented beginning than current models allow. In the domain of stellar physics, even familiar stars hide secret behaviors. There are stars that pulse in irregular, chaotic rhythms, so-called variable stars that defy the models meant to predict their light curves. There are magnet-Rs, neutron stars with magnetic fields a trillion times stronger than Earth's, capable of emitting bursts of gamma radiation that can outshine entire galaxies for brief moments. These stellar outbursts carry within them the fingerprints of nuclear matter under conditions that cannot be replicated on Earth, opening a window into realms of pressure and density we can scarcely imagine. Then there is the persistent riddle of entropy and the direction of the cosmos. While stars burn and galaxies collide, the universe as a whole seems to drift toward thermodynamic stillness, a state of maximum entropy, the so-called heat death. Yet, from this march toward disorder, complexity arises. Life, consciousness, and structure emerge in defiance of this trend, only to eventually dissolve back into equilibrium. What strange balance permits the rise of order in a universe ruled by chaos? Is entropy merely a statistical shadow, or does it hide deeper, undiscovered laws of cosmic evolution? Some cosmologists propose that our universe may be entangled with others, a multiverse not just of possibility, but of quantum interconnection. In such a scenario, the properties of our universe are influenced by the wave function of the multiverse itself. Quantum decoherence might be the process by which countless realities split and evolve, each with its own stars, laws, and histories. We may be living in just one thread of an infinite tapestry where every choice branches a new cosmos, every possibility a realized world. Even silence becomes meaningful in this cosmic framework. The absence of signals from alien intelligences, the so-called Great Silence, could be interpreted not as evidence of emptiness, but as a phase in a larger evolutionary curve where civilizations pass quickly into digital transcendence, fold themselves into black holes, or evolve beyond detectable forms. Some may deliberately hide, operating in quiet harmony with cosmic entropy, observing rather than communicating. Others may exist in wavelengths or dimensions we are not yet equipped to perceive. Still, despite the vastness and silence, we listen. We send golden records into the stars, tune radio telescopes to the static between galaxies, and dream of contact, not just with other beings, but with the universe itself. Every question we ask is an act of connection, a line thrown into the dark, hoping to hook a truth, a pattern, a voice. And when the answer comes, whether in data, in math, or in the stillness between thoughts, it changes us, reshaping the edges of what we believe to be real. Because to explore the universe is not just to chart the heavens, but to search the hidden architecture of meaning etched in starlight, in silence, and in the gravity that binds all things. Among the deepest unknowns lies a question both intimate and vast. Why does the universe allow itself to be known? Why do the laws of physics display such elegant regularity, permitting minds made of matter to uncover patterns in the stars, the particles, the flow of time itself? The cosmos, in all its staggering complexity, remains curiously intelligible, a quality that has stirred wonder in scientists and philosophers alike. It is as though reality contains within it the blueprint of its own deciphering. As we venture further into the frontier of the unseen, we confront ideas that challenge not just our instruments, but our intuition. One such concept is the idea of emergent space-time, a growing school of thought suggesting that space and time are not fundamental, but arise from something deeper. In this view, what we perceive as distance and duration might emerge from entanglements of quantum information, from the complex web of relationships between particles. Space-time, in this sense, is not the stage, but the shadow cast by a deeper structure, one still hidden beneath the threshold of comprehension. This notion opens doors to another profound puzzle. Could the universe be fundamentally computational? Some theorists argue that the laws of physics resemble algorithms, that particles behave like bits of information being processed by the universe itself. If true, then reality may operate like a vast, decentralized computer, an infinite processor not built by any hand, but emerging naturally from mathematical necessity. In such a framework, galaxies become data structures, stars subroutines, and consciousness a recursive pattern shaped by feedback and memory. Meanwhile, the study of ancient light continues to reveal quiet anomalies. Beyond the well-mapped peaks and troughs of the cosmic microwave background, there are cold spots, regions where the temperature dips more than models predict. Some suggest they're the result of voids in the structure of the universe. Others speculate they might be signs of collisions with other universes, leaving faint bruises where realities have brushed together at the edges of expansion. If such contact occurred, it would mark the first evidence not just of parallel universes, but of interaction between them. Exotic astrophysical objects continue to reshape our boundaries. Consider boson stars, hypothetical, transparent stars made not of baryonic matter but of ultralight bosonic particles, possibly including dark matter candidates. These objects, if they exist, would be nearly invisible to traditional observation methods, yet exert gravitational effects akin to black holes, without an event horizon. Detecting one would be revolutionary, an entirely new class of object, bridging particle physics and cosmology in unexpected ways. In another corner of theory lies the tantalizing concept of time symmetry breaking. While most physical laws run identically forward and backward in time, the observable universe does not. Events unfold, entropy increases, and the past appears fixed while the future remains open. But some speculative models suggest a mirrored universe may exist on the other side of the Big Bang, a cosmos where time flows in reverse, where entropy decreases, and where particles behave as our antiparticles do here. If true, the Big Bang would not be the beginning, but a boundary between twin realities expanding in opposite directions through time. And within our own galaxy, there are stars moving far faster than they should, hypervelocity stars, some ejected by interactions with black holes, others of uncertain origin. Their presence raises questions about the hidden dynamics of the galactic core and the long-term gravitational ballet played out across millions of years. These rogue stars travel alone, flung into intergalactic space, carrying with them the stories of violent encounters in the heart of our Milky Way. Elsewhere, closer to the silence of deep interstellar space, lie interstellar molecules, complex chains of carbon, hydrogen, oxygen, and nitrogen drifting between stars. Some of these molecules are precursors to life, and their presence suggests that the basic chemistry of biology is not confined to Earth. It raises the possibility that the seeds of life, amino acids, sugars, and nucleobases, may be widespread across the galaxy, waiting for the right combination of energy, water, and time to spark into awareness. And as we continue to refine our models, we encounter a more philosophical tension, the boundary between explanation and mystery. With each new insight comes the recognition that some questions may not have final answers, only deeper forms of wonder. The drive to know may itself be a cosmic imperative, embedded in the very structure of the universe, as natural as gravity, as relentless as time. We are, after all, a way for the universe to know itself, not merely spectators, but participants in a vast unfolding, shaped by stardust and curiosity, gravity and imagination. The mysteries persist, not as obstacles, but as invitations, beckoning us ever further into the darkness, toward whatever lies beyond the edge of understanding. There are moments when, gazing into the deep sky, one is struck not only by its immensity, but by the profound subtlety with which the universe expresses itself. It is not merely vast, it is intricate. And it is in that intricacy, in the whisper of distant particles and the shimmer of ghostly radiation, that we begin to sense a hidden order still waiting to be uncovered. In recent years, scientists have begun to consider the possibility of hidden sectors, entire realms of particles and forces that do not interact with ordinary matter except through gravity. These hidden sectors could contain their own forms of matter, their own interactions, perhaps even their own versions of complexity or life, unfolding entirely detached from the visible universe. If true, our cosmos may be only a fragment of a much richer whole, a single thread in a vast weave of realities layered atop one another, mostly blind to one another's existence. Within black holes, the very notion of space and time breaks down. Some speculative models propose that the singularity at the center may not be a point of infinite density, but a bridge, a wormhole to another region of space-time. In these models, known as Einstein-Rosen bridges, a black hole might connect to a white hole somewhere else in the cosmos, ejecting matter and energy in a different time or dimension. If such phenomena exist, they could function as the universe's own circulatory system, recycling matter, redistributing entropy, and perhaps even permitting passage across otherwise impassable distances. Quantum field theory paints an even stranger picture, that empty space is not truly empty but filled with zero-point energy, the lowest possible energy state of a quantum system. Some theories suggest this vacuum energy could be harnessed or that it might explain the repulsive force of dark energy that accelerates the universe's expansion. But the energy density predicted by theory and the energy observed in cosmic expansion differ by a factor of 10 superscript 1 superscript 2, the largest discrepancy between theory and observation in all of science. It is as though the universe is balanced on a razor's edge, its structure delicately tuned by some principle we have yet to glimpse. Then there are questions about the beginning, not just the Big Bang, but what, if anything, came before. Some cosmological models, like loop quantum gravity, suggest that time may not have a beginning in the traditional sense. Instead, the Big Bang might have been a bounce, a transition from a previous collapsing universe into our expanding one. In such a view, the cosmos is eternal, undergoing cycles of birth, death, and renewal. Each universe carries the echoes of the last, evolving not in a straight line but in spirals across eons. Galaxies themselves may not be the stable structures we once believed. They spin too fast for their visible mass, prompting the hypothesis of dark matter, but some alternative theories propose that gravity itself behaves differently at galactic scales. Modified Newtonian dynamics, or MOND, suggests that at very low accelerations, gravity deviates from Newton's laws. If this holds true, then our understanding of one of the four fundamental forces may require a profound revision, potentially revealing new layers of structure in the universe's very foundation. In the discipline of astrobiology, another question emerges, not just whether life exists elsewhere, but how different it might be. We often search for familiar markers, liquid water, carbon chemistry, atmospheres resembling Earth's. But life, if shaped by different conditions, could arise in forms we would not recognize. Silicon-based organisms being sustained by ammonia oceans or sentient clouds of plasma drifting through magnetic fields, all are speculative, yet not forbidden by physics. In our search for others, we may be blind to life not because it is absent, but because it is alien beyond our frameworks of recognition. And what of intelligence itself? On Earth, intelligence is bound to neural networks, brains of various shapes and sizes. But there is no reason to assume this is a universal rule. Intelligence might arise in crystalline lattices, in swarms, in fields of quantum coherence. There could be forms of awareness that emerge on geological timescales or civilizations that encode memory in gravitational waves communicating across epochs instead of moments. The universe may be teeming not just with life, but with minds whose silence is not absence, but difference. Our search then becomes not only a quest for knowledge, but a transformation of perception. We must learn to look without expectation, to listen without bias. For the cosmos is not obligated to resemble our dreams, it simply is. And what it is, in its deepest layers, remains veiled behind the limits of current theory, instrumentation, and imagination. But those limits are not fixed. They expand with every question asked, every signal detected, every anomaly studied. In the quiet persistence of discovery, we inch closer to truths that were once the stuff of myth, realities that do not merely describe the world, but re-enchant it. And with each new layer uncovered, we find that the universe does not shrink in its mystery, but deepens. An endless unfolding, where wonder is not a beginning, but a destination. Somewhere between the radiance of newborn stars and the hush of collapsing voids, the universe murmurs secrets through symmetry and silence. As our tools sharpen and our models evolve, we are confronted with the realization that we have only begun to scratch the surface of an intricately ordered cosmos, one that seems, paradoxically, both knowable and eternally elusive. A growing area of interest in theoretical physics lies in the strange interplay between quantum entanglement and geometry. Recent discoveries suggest that the very shape of spacetime, the curvature, the connectivity, the causal structure, may emerge from patterns of entanglement among quantum particles. In this vision, the fabric of reality is not woven from matter or energy, but from information itself. Space, as we experience it, might arise from the invisible threads of correlation, threads that tie particles together, no matter how distant, in a silent choreography beyond classical logic. Meanwhile, deep beneath the frozen crusts of icy moons like Europa and Enceladus, entire oceans churn in darkness, kept liquid by tidal flexing and the internal heat of their cores. These subsurface oceans may host hydrothermal vents similar to those on Earth, places where life once ignited in the absence of sunlight. Here, in alien waters untouched by starlight, life could arise from chemistry alone, evolving in complete isolation. If discovered, such life would be a second genesis, a confirmation that biology is not an earthbound miracle but a cosmic inevitability. Elsewhere, time behaves strangely not only near black holes but potentially at the quantum level itself. There are theories in which time is not fundamental but emergent, a construct that arises only when particles interact in specific ways. In such models, the universe exists as a timeless state until observers and measurements give rise to temporal flow. This radically reorients our view of causality and suggests that what we perceive as the past unfolding into the future may be a kind of illusion, an artifact of perception, not an absolute structure of the cosmos. On the cosmic stage, the end remains as mysterious as the beginning. While many models suggest a slow, cold fading into entropy, the so-called heat death, others propose more exotic finales. In a Big Rip scenario, the expansion of the universe accelerates to such a degree that galaxies, stars, planets, and eventually atoms themselves are torn apart by the ever-growing stretch of space-time. Alternatively, the universe might undergo a phase transition, suddenly and catastrophically shifting to a lower-energy vacuum state, obliterating all structure at the speed of light. These are not just mathematical curiosities, they are possible endpoints written into the equations that describe our universe's fate. In parallel, we must consider the anthropic principle not merely as a philosophical stance, but as a clue. The physical constants of our universe appear fine-tuned for complexity and life. Alter any one of them slightly and stars might never form, chemistry might fail, or time itself might behave too erratically for thought to exist. Some interpret this as evidence for a multiverse, an ensemble of universes, each with different laws, where we just happen to inhabit the one where observation is possible. Others suggest it points to deeper principles we have yet to uncover, a hidden necessity behind the apparent chance. Still, the deepest mysteries may lie not in the grandiose, but in the subtle. The way particles acquire mass through the Higgs field, the precise ratios of fundamental forces, the symmetries that break to allow the birth of matter, these delicate mechanisms are not fully understood. They are the quiet scaffolding behind everything. The starlight, the air we breathe, the synapses that fire as we wonder. In the shadows of galaxies, where light bends around unseen mass and silence outweighs illumination, the search continues. New detectors are being tuned to capture whispers of primordial neutrinos, gravitational waves from the earliest instants, and spectral signatures of exotic elements in ancient starlight. Each observation adds another piece to a puzzle that may never be finished, but which compels us endlessly onward. And always in the background of this inquiry is the profound strangeness of consciousness itself. That we can ask these questions, that we can build models, devise experiments, and dream of other worlds, is perhaps the most mysterious fact of all. The universe is not indifferent to our awareness of it. In some fundamental way, it seems to respond. Through us, it contemplates itself. So we continue not to conquer the stars, but to commune with them. Not to master nature, but to understand our belonging within it. Every anomaly, Every unexpected signal, every mathematical surprise is a thread pulled from a tapestry far larger than we can yet see. And though we may never grasp its entirety, it is enough to know we are part of its pattern, drawn into its mystery by light, gravity, thought, and time. In the stillness between signals, in the voids between galaxies, we find the cosmos not lacking in meaning, but saturated with it. For every region of darkness, every silence on the cosmic dial invites not emptiness, but the next great question. And so, with patient determination, we stretch our instruments toward the unknown, searching not only for what is, but for what could be. One such frontier lies in the strange realm of cosmic topology, the global shape of the universe itself. While we often imagine space as infinite and flat, the true geometry may be far more exotic. The universe could be curved into a hypersphere, a torus, or a multidimensional manifold beyond our capacity to visualize. In such geometries, light could eventually circle back to its origin, meaning that the distant galaxies we observe might be ghost images of our own, seen from a different cosmic angle and a much earlier time. If proven, we would inhabit a universe that folds back on itself, a cosmic hall of mirrors, timelessly echoing its own structure. Elsewhere, the field of neutrino astronomy offers new ways to listen to the deep cosmos. These nearly massless particles, born in nuclear reactions and supernovae, barely interact with matter. They travel vast distances unimpeded, carrying pristine information from the most violent and hidden events in the universe. Unlike photons, which scatter and blur, neutrinos preserve their origin stories, whispering tales from the hearts of collapsing stars and the birth of the elements. Through them, we may glimpse not only what is visible, but what is fundamentally concealed. Quantum mechanics continues to defy classical expectation. Take vacuum decay, a theoretical event where a more stable configuration of the universe's quantum fields could spontaneously emerge, obliterating the current laws of physics at the speed of light. While deeply speculative, the mere possibility invites humility. What we take as stable, the forces, the particles, the fabric of space, might only be metastable, one version of reality suspended in a wider, shifting quantum landscape. And in the corners of exoplanetary science, we're beginning to consider worlds with biosignatures unlike our own. Some exoplanets, tidally locked to their stars, may have one eternal day and one endless night. Others orbit red dwarfs that flare with violent radiation. Life in these places, if it exists, would have adapted to conditions unimaginable on Earth, perhaps using biochemistries resistant to radiation or existing in subsurface oceans beneath layers of shielding ice. Our definitions of habitability are evolving, driven by the realization that life may not require the comforts of Earth, only the persistence of chemistry and time. Another quiet puzzle is the apparent scarcity of intermediate mass black holes, those that fall between the stellar mass remnants of dead stars and the supermassive titans that anchor galaxies. Their absence defies predictions. Are they rare or simply difficult to detect? Did they merge into larger structures quickly in the early universe, leaving behind little evidence? Or do they hint at unknown physics governing the growth and collapse of matter under extreme conditions? Then there is the phenomenon of cosmic dust, tiny particles drifting through interstellar and intergalactic space. Though often dismissed as mere obscuration, dust plays a pivotal role in star formation, planetary chemistry, and the cooling of gas clouds. It may even carry the molecular precursors of life between solar systems. These grains, forged in the depths of ancient stars, are the seeds of future worlds, interstellar messengers of destruction and creation alike. In the vast datasets now generated by sky surveys, machine learning tools are beginning to identify patterns that human eyes have missed. Anomalous light curves, irregular transit signals, and unexplained bursts are being cataloged and flagged by algorithms that do not tire, do not forget, and do not carry human bias. With their help, we may uncover classes of objects never before imagined, stars with behaviors outside of known physics, artificial phenomena, or entirely new celestial mechanisms. And at the philosophical edge of cosmology lies the question of simulation. Some theorists entertain the unsettling idea that the universe is not fundamental but emergent from computational processes, its particles and forces mere byproducts of deeper rules running on a substrate we cannot observe. It's a hypothesis that cannot be easily tested, yet one that gains intrigue from the mathematical precision of physical law, the digital appearance of certain quantum phenomena, and the strange thresholds of observability embedded in reality. Still, perhaps the greatest mystery is the mystery of coherence itself. That across billions of light years and nearly 14 billion years, the universe holds together. Its laws do not unravel. Its particles do not forget their symmetries. Structures persist, even as entropy increases. In this coherence, we find the strange beauty of a cosmos that not only births complexity, but allows it to endure. And so we continue not because we expect final answers, but because the act of asking is itself part of the cosmic story. Every telescope aimed upward, every detector cooled in underground silence, every theory scribbled on a blackboard is an echo of the same instinct that first drove our ancestors to look up in wonder. That we are here, that we can wonder, and that the universe responds with mystery. This is the dialogue we were born into. One that began long before us and will continue long after. Beyond the veil of the visible cosmos, beyond the reach of even our most sensitive instruments, lies a territory not of emptiness, but of potential realms where the laws of physics may take on unfamiliar forms, and where time, gravity, and even identity itself might operate under rules we have yet to imagine. Recent developments in string theory and M-theory suggest that our universe may be but one membrane, a brain floating in a higher dimensional space. In this vast multidimensional arena, countless other brains may exist, each potentially harboring a universe with its own dimensions, particles, and laws. Collisions between these brains could trigger events like the Big Bang, suggesting that the birth of our universe was not the beginning of everything, but merely a ripple in a far deeper and stranger ocean. If this is true, our cosmos is not a singular creation, but one unfolding chapter in a multiversal epic of unimaginable scale. In that light, gravity itself becomes suspect. Unlike the other fundamental forces, gravity is extraordinarily weak, so weak that a single magnet can overcome the gravitational pull of an entire planet. Why this disparity? Some models propose that gravity is not weak by nature, but diluted, leaking into other dimensions beyond our own. If gravity is shared across multiple realities, it would explain its feebleness here and suggest that our universe is not a closed system, but part of a larger gravitational continuum. Meanwhile, in the cores of neutron stars, those dense stellar remnants formed in supernovae, we approach the very limits of matter. Crushed into a state beyond atoms, protons and electrons fuse into neutrons, and perhaps even stranger particles emerge. Quark matter, hyperons, or even more exotic forms of degenerate matter may reside there, trapped beneath a crust of unimaginable pressure. These stellar corpses are cosmic laboratories where the behavior of matter under the most extreme conditions could illuminate the unification of forces or hint at physics beyond the standard model. And then, at the far reaches of possibility, there are ideas even more speculative, like Boltzmann brains, self-aware entities spontaneously arising from random fluctuations in the quantum vacuum. Though wildly improbable, over infinite timescales, such fluctuations could occur. These disembodied minds, floating in isolation, would have no past, no future, only a flash of thought. A paradox that forces us to re-examine assumptions about probability, entropy, and the nature of consciousness in an eternal universe. Another frontier emerges in the study of time asymmetry in biological systems. Life, unlike most natural processes, seems to defy entropy, creating complexity, preserving information, and generating memory. How life arose from non-living matter remains one of the most profound unsolved questions. Some theories propose that the origin of life may require not only the right chemistry, but a local reversal or suspension of thermodynamic decay, a fleeting oasis of order in a universe tending toward disorder. In this sense, life is not just a phenomenon within the universe, it is a resistance to its direction. Elsewhere, dark energy continues to mock our expectations. It is not simply a placeholder for ignorance, it dominates the dynamics of the cosmos, composing nearly 70% of the total energy content of space. Yet it does not clump, it does not shine, and it accelerates the expansion of space itself without warning or symmetry. Its constancy, its pressure, its uniform distribution all remain unexplained. It is as though the vacuum itself has a will, gently pushing the cosmos outward with a quiet but relentless hand. And while we observe, measure, and theorize, time itself advances, drawing us ever deeper into a future as unknown as the past was once unknowable. With each new discovery, the cosmos grows both clearer and more mysterious. The clarity reveals structure, beauty, and order. The mystery invites humility, curiosity, and awe. We are cosmic listeners sifting through noise and pattern, trying to separate signal from silence. Yet in the end, both speak to us. The silence tells us where not to look again. The signal reminds us that something is there, something ancient, something vast, something still unfolding. And as the stars continue their distant murmuring, as galaxies drift across the sky like ancient ships in the sea of space-time, we remain here, sentient dust, momentarily illuminated, trying to read the universe as if it were a language. Not to decode it completely, but to hear, however faintly, its voice. For the greatest mysteries are not necessarily those we have yet to solve, they are the ones we are only just beginning to ask. There is a quiet majesty in the fact that the universe does not yield its answers easily. It resists simplification. Its truths emerge not in thunderous revelation, but in faint, scattered signals, an unexplained curve in a light spectrum, a subtle anomaly in gravitational lensing, a discrepancy in the decay rate of particles. The cosmos speaks in riddles, and each solved riddle opens the door to deeper questions. Among the most delicate of these riddles is the mystery of cosmic isotropy, the idea that, on the largest scales, the universe looks the same in every direction. For decades, this assumption held strong, but now subtle irregularities are being noticed. Quasar alignments, hemispheric anomalies in the cosmic microwave background, peculiar flows of galaxy clusters all suggest that there may be a preferred direction, a cosmic axis lurking within what was once thought to be perfect randomness. If confirmed, it would rewrite our cosmological principle, suggesting that the universe bears not only structure but orientation, a direction imprinted perhaps at its birth. Equally perplexing is the concept of vacuum metastability. According to some interpretations of the Higgs field, the current vacuum state of our universe may not be the lowest possible energy state. If this is true, the universe is perched in a false minimum, stable for now but vulnerable to quantum fluctuations. A sufficiently powerful event or a spontaneous fluctuation could trigger a transition to a lower energy vacuum, rewriting the very fabric of physics in an instant. The laws we know would vanish, replaced by a new and alien reality expanding outward at light speed, erasing everything in its path. It is not a question of fear, but of recognition that even the most stable-seeming things may rest on impermanent foundations. Beyond the physical, there are questions that blur into the existential. Why is the universe comprehensible at all? Why do mathematics and physical laws mirror one another with such uncanny precision? From planetary orbits to quantum fields, the language of numbers seems embedded in nature itself. Some have suggested that the universe is not merely described by mathematics, it is mathematics. Others speculate that consciousness plays a more central role than we dare admit, not as a passive observer, but as a necessary participant in the unfolding of reality. Still deeper are the questions of emergence, how complexity arises from simplicity. From hydrogen and helium come stars, from stars, elements, from elements, planets, from chemistry, biology, from biology, thought. Nowhere in the fundamental equations is there a line that says, and here there will be wonder. And yet, here it is. Self-awareness, creativity, memory, grief, none of these were guaranteed by the Big Bang, and yet they bloomed. Somewhere, amid entropy and expansion, the cosmos gave rise to meaning. In parallel, scientists have begun to investigate the possibility of cosmic archaeology, studying the fossilized light of the early universe not just to understand its structure, but to uncover rare or one-time events buried in the vast background of space. For instance, primordial gravitational waves from the inflationary epoch could contain clues about the birth of the universe itself. Wrinkles in the fabric of reality that would confirm or shatter long-held theories about the earliest instance of existence. These signals, if detected, would not only stretch our understanding, they would touch the closest thing we have to a cosmic memory. And then there are the black hole mergers, immense, invisible cataclysms that send tremors through space-time. With each detection by gravitational wave observatories, we capture not just an event, but a voice from the farthest depths of time and space. These mergers are not simply collisions of matter, but of history's two ancient stars that lived, died, and spiraled into one another over billions of years, culminating in a moment of such ferocity that it alters the shape of the universe itself. In between these events, in the long, quiet stretches of cosmic time, the universe continues its steady transformation. Galaxies collide, stars burn out, new worlds form from the ashes of the old. Over unimaginable eons, even the structures we now consider permanent will dissolve. The Milky Way will merge with Andromeda, stellar remnants will cool into darkness, and matter itself may decay into silence. And yet, even in this far future cosmos, governed by the slow, patient rhythm of entropy, new mysteries may emerge. Not every answer leads to closure. Some open paths to vistas we have yet to imagine. The pursuit of knowledge is not just about data or discovery. It is about communion. To study the cosmos is to place oneself in relation to the whole, to understand not only how things are, but how we belong. The universe is not a distant abstraction. It is the substance of our very being. Its atoms are our atoms. Its forces govern our cells. Its history is our story. And perhaps that is the most astonishing truth of all. That in a universe so vast, so ancient, so cold in its indifferent scale, there exists a species capable of asking why. Capable of looking into the abyss and recognizing not fear, but wonder. Capable of naming the stars and listening for the songs they have yet to sing. Even now, as our detectors sweep the skies and algorithms scan for patterns hidden in oceans of data, the universe remains composed of silences deeper than its signals. But these silences are not empty. They are pauses in a grand composition, intervals between cosmic notes still reverberating from the first act of creation. And somewhere within them, perhaps, lies the next revelation waiting patiently to be noticed. One of the quiet revolutions in modern cosmology comes not from the edge of the universe, but from the edge of thought, the possibility that space-time itself is not continuous. Just as matter is made of atoms, space-time, too, might be composed of discrete units, a kind of quantum lattice so small and fine that it escapes all current observation. This idea, sometimes explored through loop quantum gravity and other quantum gravity theories, suggests that space and time are not infinitely divisible but granular. If true, it would mean that the smooth flow of time we experience is an illusion, like the fluid motion of a film made from countless frames too fast to detect individually. There are also suggestions that the constants of nature, the speed of light, the fine structure constant, the gravitational constant might not be constant after all. Observations of light from the most distant quasars have hinted, however faintly, at variations in these values across space and time. Such a discovery, if confirmed, would be nothing short of seismic. It would imply that the laws of physics are not fixed, but evolve, that the cosmos itself is not governed by eternal truths, but by a shifting framework, subtly rewriting its own code as it expands. And in the realm of dark matter, the silence grows stranger. We know it is there, we see its gravitational fingerprints on galaxies, its invisible weight sculpting the large-scale structure of the universe. Yet every effort to detect it directly has failed. No collision, no particle decay, no signal. Some now wonder, what if dark matter is not a particle at all? What if it's a field, or a reflection of our incomplete understanding of gravity, or a projection of mass from another dimension, bleeding into ours through the subtle geometry of folded space? As we press further, we also encounter the eerie notion of cosmic censorship, not as a law of physics, but as a metaphysical veil. Some singularities may exist forever cloaked by horizons, inaccessible and unknowable. Others might be hidden not by light, but by principle, information locked behind causal boundaries that no signal, no probe, no mind could ever cross. It raises a fundamental question: are there parts of the universe that are, in principle, unknowable, not due to technological limits, but because the structure of reality prohibits access? Meanwhile, time itself may be branching, rather than linear. In interpretations of quantum mechanics like the many worlds theory, every decision, every quantum event causes the universe to branch, spawning countless versions of reality where every possible outcome occurs. If this is true, then the cosmos is not a singular unfolding, but an infinite blossom of possibilities, countless timelines growing in tandem, layered in dimensions beyond our senses. We live not in the universe, but in one of an immeasurable number of coexisting histories, each as real as our own, each with its own sky, its own version of events, its own unrepeatable path. Even our own planet holds unresolved cosmic puzzles. Tiny variations in Earth's rotation, subtle shifts in its magnetic field, and unexplained signals in the ionosphere may carry echoes of solar phenomena or even distant astrophysical events. Earth is not isolated, it is immersed in the environment of space, a small world whose air, oceans, and crust respond to forces and radiations far beyond the atmosphere. Our planet listens to the stars in ways we have only just begun to measure. And within us, the observers, the thinkers, the question-askers, resides a final enigma: consciousness. We are patterns of neurons, yes, but also something more, organisms capable of abstraction, of envisioning the heat death of the universe and the fusion of galaxies we will never see. This capacity to imagine beyond the present, to simulate futures, to ponder unanswerable questions, it is a phenomenon so far unreplicated, unexplained, and perhaps entangled with the nature of the universe itself. The cosmos is not silent because it lacks meaning. It is silent because its meaning is vast, too vast to be delivered all at once. It unfolds in stages, in fragments, in signals that ask to be sought rather than simply received. And so we build better telescopes, we cool our detectors to the threshold of quantum noise, we invent new mathematics to express what we can barely intuit. We are the universe's echo chamber, recording, reflecting, questioning. In doing so, we do not merely observe the cosmos. We become part of its unfolding narrative. A species whose destiny may be to wonder, endlessly and without final answer, beneath a sky that has never run out of mysteries. Across the gulf of time, in the afterglow of the primordial fireball, The universe whispers stories older than stars, stories etched into the very structure of reality, waiting to be heard. It is not a silence of absence, but a silence of scale. The cosmos moves slowly in epics and eons, and we ephemeral, flickering minds strain to catch even a glimpse of its unfolding. One of the most compelling frontiers now emerging is the study of baryogenesis, the process that produced the matter we are made of. In the earliest fractions of a second after the Big Bang, particles and antiparticles were born in nearly equal numbers, and yet somehow matter won. The mechanism by which this imbalance occurred remains elusive. Some theories invoke CP violation, subtle asymmetries in the behavior of particles and antiparticles. Others suggest that entirely new physics operated in the early universe, leaving behind only this faint residue, the atoms that form stars, planets, oceans, and ourselves. The concept of cosmic inflation, too, is under renewed scrutiny. While it elegantly solves several problems in cosmology, such as the horizon and flatness problems, it also raises new questions. What caused inflation to begin, and why did it end? Did it happen once, or is it still occurring in distant, unreachable regions, spawning a fractal multiverse of endlessly budding domains? If eternal inflation is real, then our observable universe may be just one pocket within an ever-growing, chaotic whole, a bubble adrift in a quantum foam of newborn realities. And yet, within this vastness, the cosmic web reveals a strange elegance. Galaxies are not scattered at random, but woven into filaments and nodes that span hundreds of millions of light-years. These structures are the fossilized footprints of sound waves rippling through the early plasma of the universe, echoes frozen in time. The universe has memory, and its memory is spatial. What we see today is not just matter, it is history crystallized into form. Meanwhile, time itself may be stranger than we think. In some theoretical frameworks, time is an emergent property, arising not from an underlying ticking clock, but from entanglement, correlation, and thermodynamic flow. In such models, time does not exist in the absence of interaction. Without change, without observers, without measurement, there is no before or after, only the potential for events. This raises haunting possibilities. Could entire regions of the universe exist timelessly, awaiting only the touch of an observer to bring time into being? In another speculative thread, physicists are exploring the idea of mirror matter, a hidden counterpart to ordinary matter that interacts only via gravity and possibly a few weak forces. If it exists, it might form entire galaxies invisible to our instruments, passing through us without a trace. Some have proposed that dark matter itself could be composed of mirror atoms, mirror stars, even mirror life. Not a parallel universe, but a reflection of our own existing silently alongside us. The cosmos also offers strange exceptions. Blinking stars whose luminosity drops without explanation. Galaxies that appear far more massive than their visible content suggests. Gamma ray bursts that erupt with energies no known mechanism can fully explain. These anomalies do not always make headlines, but they are the cracks through which future revolutions in science may pour. Every unexplained data point is a lantern swinging in the dark, casting brief, dancing shadows on walls we have yet to name. And beyond the observational, there is the imaginative. Hypothetical constructs like Dyson spheres, stellar-scale structures built by advanced civilizations to harness the energy of their stars. We have never seen one, and yet we search the skies for their signatures, for the unnatural dimming of stars, for the waste heat of planetary-scale engineering. Not because we expect to find them soon, but because to look is to admit that intelligence could be universal, that we are not necessarily the end, but perhaps the beginning of something far larger. Even within our own biology, we begin to glimpse cosmic echoes. The elements that make us carbon, nitrogen, oxygen were forged in the deaths of stars. The water in our cells may predate the Earth itself. The very ability to wonder, to question, is built from dust shaped in ancient crucibles. We are not separate from the cosmos. We are its product, its expression, its way of folding in on itself and becoming aware. And so we keep listening, with radio dishes scanning the void, with spacecraft trailing the solar wind into interstellar space, with thought experiments etched into chalk and silicon. We persist not because we expect a final answer, but because asking is what we do. It is what the universe does through us. Perhaps the cosmos will never fully reveal its purpose, if it has one. Perhaps there is no grand destination, only an endless unfolding. But within that unfolding, we find something precious. The chance to witness, to marvel, and to belong to something immeasurably larger than ourselves. Something that does not need us, but nevertheless includes us. Something that stretches not just across space and time, but through consciousness, curiosity, and the quiet, persistent drive to understand. As we delve deeper into the cosmos, we begin to realize that the universe does not just challenge what we know, it challenges how we know. It forces us to refine the very framework of inquiry, to ask not only what is out there, but what is possible to know, and what are the limits of knowing itself. These are not abstract questions. They echo in the data from distant quasars, in the silence between stars, and in the paradoxes that emerge at the intersection of relativity and quantum theory. Among these paradoxes lies the holographic principle, a radical idea suggesting that everything we experience in 3 dimensions, including time, may actually emerge from information encoded on a 2-dimensional surface, like a cosmic boundary or horizon. If this principle holds true, then our reality is not what it seems. The universe we move through, the space we stretch into, the time we flow across, might all be projections from a more fundamental realm of pure information. In this view, black holes do not destroy information, they store it in a code we have only begun to decipher. In the same breath, we confront the enigma of cosmic acceleration. Dark energy, that elusive and invisible pressure driving galaxies apart, remains one of the most profound mysteries of modern physics. Unlike any known force, it does not pull, but pushes. It does not concentrate, but spreads evenly throughout space, growing more dominant as the universe expands. Its origin could lie in quantum fluctuations, in the shape of higher dimensions, or in entirely unknown physics. Yet we feel its influence in every measurement of distance, every redshift of light from ancient galaxies. It is a ghost force, guiding the rhythm of cosmic time. Simultaneously, new fields like quantum cosmology are attempting to model the birth of the universe not as a moment of classical explosion, but as a quantum event, an emergence from a timeless, spaceless state. In these models, the universe is born not from nothing, but from a quantum potentiality, where all possible configurations exist in superposition. The Big Bang becomes less an origin and more a phase transition, a sudden crystallization of one history from a sea of infinite ones. What caused the universe to take this path, with these laws and this chemistry, remains unanswered. But the very fact that we can ask this question is astonishing. On the observational frontier, we now detect exoplanets not only by their transits across stars, but by analyzing their atmospheres, looking for oxygen, methane, carbon dioxide, or the spectral fingerprints of artificial compounds. These are early steps in a long journey, one that may eventually identify the chemical breath of alien ecosystems or the exhaust of faraway machines. In the faintest traces of infrared light, we may find the presence of life or the memory of it. Meanwhile, our understanding of time is being further complicated by entropic gravity theories and temporal non-locality. Some physicists suggest that gravity itself may arise from entropy gradients, the tendency of information to spread and disorder to increase. In such a framework, gravity is not a fundamental force, but a thermodynamic effect, a kind of statistical illusion emerging from deeper rules of information flow. If that is so, then time, mass, and space are secondary illusions of scale and energy. Our world becomes a thermodynamic mirage, held together not by immutable forces, but by probability itself. In the silence of deep space, we've also detected fast radio bursts, millisecond-long pulses of unknown origin, arriving with no clear pattern from distant galaxies. Their power is immense, their frequency puzzling, and their sources remain unconfirmed. Some believe they are the signatures of neutron stars or magnetars. Others wonder if they might be artificial signals from technologies far beyond our own. They may be cosmic thunder or distant beacons. Either way, they remind us how much remains hidden just beyond our reach. And all the while, the universe continues to evolve. Stars are born, live, and die. Galaxies drift, merge, and fade. Planets form in the remnants of stellar funerals, and on some of those planets, perhaps, eyes open for the first time to starlight, wondering where they are and what it means. This cycle of creation and dissolution is not static. It is a conversation. Matter becomes mind. Mind asks questions, and the questions shape the future. To explore the cosmos is to look into a mirror that deepens the more we gaze. The farther we see, the more clearly we glimpse ourselves not in form, but in essence. Curiosity, fragility, the ability to wonder. And through that wonder, the power to reach beyond our origins, to craft meaning from mystery, to make something sacred out of the void. Because the universe does not speak in certainties. It speaks in invitations. And we, brief though we are, have accepted the invitation to listen. Somewhere in the endless hush of intergalactic space, where no star has ever burned and no particle has ever stirred, the universe continues its quiet unfolding. Not with explosions or proclamations, but with the subtle shaping of structure, the drift of galaxies, the slow warping of space-time itself. It's not only the grand phenomena that reveal the nature of the cosmos, but also its restraint, its balance, its patience. One of the most provocative ideas emerging from theoretical physics today is that the entire universe may be governed by principles of quantum entanglement, not as an occasional phenomenon, but as a foundational engine of reality. In this view, entanglement is not merely a curiosity of particle behavior, but the stitching that binds space together. Regions of the universe that appear separated by light years may, at a deeper level, be linked by information, an invisible thread weaving together distant corners of reality, allowing the emergence of geometry, gravity, and perhaps even consciousness itself. From this foundation, a new picture of the cosmos is forming, one in which information, not matter or energy, is the most fundamental entity. In such a model, the universe is not so much a machine as it is a computation, an unfolding process in which particles are bits, forces are algorithms, and time itself is the ticking of an invisible processor. This is not metaphor. It is mathematics. And as strange as it sounds, it may explain why the laws of physics are so exquisitely precise, because they are, in a very real sense, code. Meanwhile, astrophysicists are investigating voids, immense regions of the universe almost entirely devoid of matter. Far from being uninteresting, these great cosmic caverns are revealing new insights into dark energy, the geometry of space, and the fate of galaxies that drift too close to their gravitational stillness. In these places, where the density of matter drops to near zero, the subtle behavior of the universe is amplified. Tiny anomalies become loud. The structure of space-time itself becomes more pronounced, less cluttered by stars and dust. In a paradoxical twist, it is in the emptiest parts of the universe that some of its deepest truths may be uncovered. Elsewhere, we're beginning to detect gravitational waves not just from black hole mergers, but from more speculative events, the collapse of exotic stars, the early tremors of inflation, even the possible vibration of topological defects left over from the earliest moments of time. These ripples in the fabric of space-time are not just confirmations of theory, they are messages from epochs otherwise lost. They offer a kind of archaeology not of stone or fossil, but of geometry, telling the story of the universe's birth with no words, no light, only curvature. At the edge of particle physics, attention is shifting towards symmetry-breaking moments when the universe, once perfectly balanced, chose imperfection. These tiny fractures in symmetry gave rise to forces, particles, and structure. Without them, nothing would exist. Why the universe broke symmetry in just the right ways to permit complexity is still a mystery. It is as though, in the infinite role of physical possibility, nature favored the improbable, creating a cosmos capable of stars, chemistry, thought, and meaning. Even in the study of black holes, we're now probing the information paradox with new tools. Theorists propose that black holes do not obliterate information, as once feared, but encode it on their horizons in Planck scale patterns. Scrambled, yes, but not erased. If true, it suggests that no event in the universe is ever truly lost. Every moment, every particle, every interaction is remembered by the fabric of space itself. The universe becomes not only a place of matter and motion, but a vast, cosmic memory. And on the frontier of time, some researchers are challenging its linearity altogether. In certain formulations of quantum gravity, past, present, and future are not distinct. All moments coexist in a timeless block, our perception of flow merely a feature of how consciousness processes information. In such a reality, time does not pass. It simply is. The future is not unfolding. It is already there, waiting for us to arrive. Within this framework, we ourselves become bridges between scales. We are made of atoms forged in stars, driven by biological imperatives honed across eons, yet capable of contemplating infinity. This is no small thing. It means that the universe in us has developed the capacity not only to evolve but to reflect. Not only to exist, but to ask why. We peer outward, but we are also peering inward. The mysteries of the universe are not separate from us. They are within us, written into our cells, echoed in our dreams, mapped into our deepest questions. We are not detached observers. We are participants in a grand unfolding, shaped by and shaping a cosmos that may be far more conscious, dynamic, and mysterious than we ever dared believe. And so we continue not out of certainty, but out of wonder. The sky does not answer every question, but it invites them, and that invitation may be the clearest signal of all. In the ever-deepening silence beyond the edge of what we can observe, the universe continues to evolve, not just in matter or in structure, but in the questions it inspires. Every breakthrough brings clarity, yes, but it also brings a widening horizon of uncertainty. The more we illuminate, the more we see how much remains hidden, like distant mountains revealed by the lifting of morning fog, only to find behind them a vast, unmapped range stretching into darkness. Among the questions that now rise into focus is one deceptively simple. What defines a universe? Is it merely a bubble of space-time with its own rules? Is it defined by its constants, its dimensions, its content? Or is a universe something deeper, defined by its capacity to generate novelty, to form complexity, to harbor minds capable of wonder? These are no longer just philosophical inquiries. As the multiverse hypothesis gains mathematical traction, we find ourselves confronting the real possibility that our cosmos is just one instance in a far larger set, each universe a different solution to the same deeper equation, each with its own version of space, time, and perhaps meaning. In that context, our own universe takes on a special poignancy. For its laws, so finely tuned for the emergence of structure, stability, and life, appear as a rare intersection of possibility. A universe where hydrogen forms, where stars burn slowly enough to seed elements across billions of years, where chemistry can give rise to memory and carbon can dream. Is this an accident? Or is it evidence of a deeper selection process, natural, anthropic, or something else entirely? Even now, the boundary between physics and metaphysics is beginning to blur. Concepts like the landscape of string theory propose a nearly infinite number of possible universes, each with a different vacuum state. And yet, among this infinity, we find ourselves in a reality that not only supports observers, but allows those observers to ask about the infinity itself. This recursive awareness, the cosmos becoming conscious of itself, is not explained by equations. It is a phenomenon unto itself. Meanwhile, in the physical universe, we begin to detect anomalies at the edges of established models. The behavior of muons in magnetic fields, the patterns of neutrino oscillations, the slight discrepancies in measurements of cosmic expansion all hint that there may be forces and particles still hidden from view. These are not just errors or noise. They are clues, faint fingerprints left by something just beyond our reach, a deeper layer of physics waiting to be uncovered. And then there is the mystery of silence. The Fermi paradox remains unresolved. In a galaxy with hundreds of billions of stars, many billions of years older than our sun, we might expect the sky to be saturated with the signs of intelligence. Yet we find none. No signals, no constructs, no technosignatures. This absence may be a profound presence in disguise. It may signal a great filter, some bottleneck that all civilizations fail to pass. Or it may suggest something subtler. That intelligence, as we understand it, is a transient phase, soon eclipsed by something quieter, more integrated with the flow of the universe. Something that does not build megastructures or send radio waves, but instead transforms into harmony with the cosmos itself. Our search thus becomes layered. We look for other Earths, yes, for biosignatures in exoplanetary skies, for echoes of alien minds. But we also begin to ask, what forms might intelligence take beyond neurons and language? Could awareness emerge in plasma fields? In the superconducting networks of pulsar magnetospheres? Could galaxies themselves be computation engines processing, evolving, reflecting? These ideas remain speculative, but the history of science warns us not to underestimate nature's creativity. Even our current understanding of death, the entropy, the heat death, the dissipation of usable energy may not be the full story. Some theories propose long-term dynamics that outlast stars, in which information is never destroyed but endlessly rearranged. In such a cosmos, nothing truly ends, it only changes form, drifting across phase transitions in complexity and coherence. A kind of immortality, not for individuals, but for patterns and echo that endures beyond its source. And through all this, we are learning to look differently. To listen not just for what we expect, but for what surprises. To read between the lines of what we observe and to question the assumptions embedded in our instruments, our models, our metaphors. For the cosmos is not obligated to present itself in familiar terms. It is under no obligation to make sense, only to be. And our role may not be to decode it fully, but to participate in its becoming. We are the question the universe asks itself. We are the improbability that became reflective, the carbon that learned to contemplate time, the matter that dares to ask what lies beyond. And though our lives are short and our tools imperfect, we carry within us the most ancient force of all, curiosity. A spark that, once ignited, refuses to dim. a light that seeks not to conquer the dark, but to understand it, and to find, even in the emptiest corners of space, a mirror. Even now, as we stand amid the golden age of cosmic discovery with telescopes peering farther than ever before, detectors tuned to the subtlest murmurs of space-time, and simulations unfolding universes within machines, we find that the greatest revelation may not be what we see, but what we sense is still missing. There is a growing awareness that the universe we observe may only be a shadow of a deeper, richer reality, one not limited to particles and fields, but woven through with patterns we have no language for yet. Among the quietest, yet most profound frontiers lies the concept of emergence, not in a poetic sense, but as a rigorous principle of nature. Complex systems often behave in ways that their individual components cannot predict. A single neuron cannot think. A trillion can dream. A few molecules cannot remember. A web of them can replicate, adapt, evolve. If emergence is a fundamental property of the cosmos, then perhaps even consciousness is not an accident but a lawful consequence of complexity, a phenomenon that may emerge wherever the right thresholds are crossed, whether in a brain, a star, or something stranger still. In parallel, a new generation of physicists is exploring whether space and time themselves are not continuous backdrops but responses to something else entirely, products of entanglement, thermodynamic gradients, or abstract informational constraints. If so, the universe may not have a location or a timeline in any absolute sense. Reality may be relational, defined by how parts of the system influence each other. There is no here or then, only the web of connection. This perspective reshapes the way we think about origin itself. The Big Bang, long seen as the singular beginning, may instead be a transition, a boundary between phases. Perhaps before our universe's observable expansion, there existed another domain, unseeable but no less real, governed by different symmetries, dimensions, or even logic. The birth of our cosmos may have been a kind of quantum tunneling, or a fluctuation across a higher dimensional landscape, leaving behind the ashes of a prior order from which we arose like dew on a cooling field. In the darkness beyond our stars, we continue to encounter the unexplained, ultra-diffuse galaxies that appear to defy gravitational logic. Massive black holes that form too early in cosmic time to fit our models. Rogue planets drifting through space, unattached to any sun, whispering of chaotic pasts and unseen dynamics in stellar nurseries. Each is a deviation from expectation, and each deviation is a teacher. Our models still cannot fully explain why the universe's expansion is accelerating now, after billions of years of relative balance. Nor can they reconcile quantum mechanics with gravity in a seamless theory. These blind spots hint at something deeper. Not a missing equation, but a missing intuition. The very shape of truth may be unfamiliar, nonlinear, multidimensional, or encoded in symmetries we have yet to discover. Meanwhile, new concepts like causal set theory suggest that time may be granular, that reality grows not continuously but in discrete jumps, like frames in a cosmic film strip. In such a universe, the future quite literally does not exist until it is born, event by event. This notion reinvigorates ancient philosophical questions. Is the flow of time an illusion? Or is it the most real thing of all, pulsing at the core of being? And through it all, the stars remain vast, radiant, silent. They burn for billions of years, shaping the periodic table one fusion at a time. From their scattered debris, new worlds are born. The same calcium that hardens our bones once floated in the atmosphere of long-dead suns. The iron in our blood was forged in supernovae. We are not just from the stars, we are the stars, reconfigured, cooled, and momentarily aware. This awareness, rare and fragile, is perhaps the most precious phenomenon we know. It is the only thing in the universe that questions its own origin, that dreams of other worlds, that invents futures, And while consciousness remains a mystery, we do not know where it begins or whether it is unique to biology. It is here, now, asking these questions. In that asking, we connect to the cosmos in a way no telescope can replicate. We are not just observing from the edge, we are part of the unfolding. The atoms of our bodies are playing out the consequences of physical laws, yes. But our thoughts, our dreams, our search for meaning, these are also patterns in the fabric of the universe. Subtle, temporary, but real. Perhaps then the universe is not cold or indifferent, not because it loves or hates, but because it includes. It allows. It permits the rise of questions that have no obvious answer. It tolerates mystery. It shelters the fragile spark of inquiry in a sea of entropy. And perhaps that is its most extraordinary quality. Not the galaxies or the black holes or the dark energy, but the space it creates for minds like ours to wonder endlessly, beautifully, and without conclusion. Somewhere in the silence between photons, between particles and waveforms, between the curvature of space-time and the whisper of quantum fields, lies a truth we have not yet named. A truth not of finality, but of perspective. The universe, as it reveals itself, seems less like a place we are trying to solve, and more like a story we are learning how to read. In this unfolding story, we find a cosmos rich not only in structure, but in process. Reality is not static, it is becoming. The universe is not merely a set of things, but a set of changes, an orchestra of transformation played across incomprehensible timescales. What we call galaxies are slow-moving fireworks, each star a brief flare of complexity in a medium that favors entropy and yet over and over again gives rise to order. In the domain of quantum mechanics, the uncertainty principle tells us that there are limits to what can be known at once. The more precisely we know a particle's position, the less we know about its momentum. This is not a technological shortcoming, but a fundamental property of reality. And perhaps this uncertainty is not a flaw, but a feature, a window through which novelty enters the cosmos. In a universe without perfect predictability, possibility survives. And with possibility, so too does creativity. Even the vacuum, long imagined as empty, is now known to be seething with activity. Virtual particles burst into existence and vanish in less than a blink, contributing to the strange behavior of space itself. This quantum foam, invisible to the eye yet measurable in its effects, may underlie everything, from the stability of atoms to the mysterious repulsive force we call dark energy. What we once called nothing is in fact an ocean of potential, a background hum of becoming that undergirds all existence. Elsewhere, on the scale of galaxies and voids, we've discovered that the large-scale distribution of matter forms a structure uncannily like the networks within a brain. Filaments stretch across cosmic distances, connecting clusters of galaxies in a web-like lattice that bears an eerie resemblance to neural pathways. While the comparison is metaphorical, it stirs something profound. Could intelligence itself be a recurring motif of complexity, arising wherever the right conditions, scales, and connections appear? Some physicists now explore the hypothesis that consciousness might not be exclusively biological. It may be an emergent property of complex systems governed not by carbon but by information flow and feedback loops. In this view, the substrate does not matter, it is the structure that counts. And if that is true, then intelligence may not be limited to planets, to organs, or to minds like ours. It could exist in forms we do not yet recognize, in the dynamics of plasma clouds, in quantum networks, or in artificial intelligences still incubating within our own machines. There is also the persistent riddle of the arrow of time. On the microscopic level, the laws of physics are time-symmetric, there is no preferred direction. And yet, on the macroscopic scale, we move inexorably forward. Eggs do not unscramble. Smoke does not return to firewood. Memory exists in one direction only. What breaks the symmetry? Is it merely entropy increasing? Or is there something deeper, something about the nature of observation itself that pins time and place? And then we confront the inescapable mystery of scale. The same equations that describe the orbit of moons can model the spiral of galaxies. The same patterns arise in river deltas and neural networks, in lightning bolts and dark matter distributions. Fractals, power laws, and symmetries recur from the subatomic to the cosmic. This self-similarity, this harmony of structure across orders of magnitude suggests a kind of elegance woven into the bones of the universe. Not imposed, but emergent. We are beginning, to listen for exoplanet weather, to map the winds of alien atmospheres, to observe the dance of light bouncing through the hazes of distant worlds in search of clues, molecules that don't belong, gases that should not coexist, patterns that hint at metabolism. Each measurement is a question: are we alone? But perhaps more fundamentally, are we rare? The answer, either way, reshapes our understanding of life and of ourselves. The further we look, the more the boundaries between disciplines dissolve. Cosmology becomes entangled with philosophy, quantum mechanics with epistemology, biology with thermodynamics. We are no longer simply asking what the universe is, but why it behaves as it does, and what it means for beings like us to arise within it, briefly conscious, briefly aware. This journey has no clear destination. There may be no final theory, no grand unifying truth that locks into place. And maybe that's the point. Maybe the cosmos is not a puzzle to be solved, but a relationship to be deepened, a dialogue between curiosity and mystery, between what is and what is possible. In the end, the greatest miracle may not be that the universe exists, or even that it can be known, but that it welcomes our questions, that it responds not with indifference, but with depth, that in our search for it, we come to know something of ourselves. Drifting through the deep interstellar dark, beyond the last traces of solar wind and into the hush of galactic voids, the universe becomes more than distant, it becomes intimate. Not because it is near, but because it is within. The elements of our bones, the spark of our thoughts, the breath in our lungs, all are drawn from stars that lived and died long before Earth had oceans. We are not passengers on this cosmic voyage. We are the voyage itself, momentarily aware of its direction. Yet for all our awareness, the universe refuses to be reduced. The more we uncover, the more it reveals that it is not built for easy answers. Consider entropy, often called the arrow of time, the law that predicts disorder will increase. And yet, from this tendency toward chaos, we witness emergence, stars, cells, minds. How does complexity arise in a universe biased toward decay? Is there an underlying counterbalance, an impulse towards self-organization woven into the thermodynamic flow? Perhaps this tension between dispersal and coherence is itself the signature of a deeper law. The cosmos might not favor order or disorder, but the tension between them. This dynamic equilibrium allows pockets of complexity to bloom. In galaxies, in ecosystems, in conscious thought. These islands of improbable structure are not anomalies. They may be the natural consequence of a universe that permits, and perhaps demands, transformation. This transformation is not only spatial but temporal. Time, which we experience as a line, may instead be a landscape. Some researchers explore the idea that past and future coexist equally, that our sensation of now is a construct of the mind assembling experiences in sequence. In such a block universe, all events, past, present, future, are eternally etched into the structure of space-time. We do not move through time. We are fixed within it, like patterns on a crystal, only appearing to flow due to the limitations of perception. From that vantage point, even the most distant moments, supernovae in ancient galaxies, the first flickers of life in Earth's oceans, the birth of new civilizations in stars yet unformed, may all be equally real. The universe may be not a film reel running forward, but a complete reel already made, already woven, already whole. And what of dimensions we cannot see? String theory and its extensions propose that reality includes not just the familiar 3 of space and 1 of time, but up to 10 or 11 dimensions, most curled so tightly they are undetectable. These hidden directions may influence the behavior of particles, the strength of forces, even the distribution of galaxies. They may cradle entire physical laws alien to our own. If true, our universe is not all there is, but merely the visible surface of a much deeper topological tapestry. We continue to scan that tapestry for threads of intelligence beyond our own. Yet so far, no signal has come. And in that silence, some speculate that advanced civilizations may not communicate with electromagnetic waves at all. Perhaps they have moved beyond physical infrastructure. Perhaps they encode information in gravitational anomalies, in neutrino bursts, in the quantum phase of vacuum fields, media invisible to our current tools. Or perhaps they no longer communicate outward at all, having turned inward, merging with machines, with mathematics, with the deep rhythms of the universe itself. If life elsewhere exists, and it seems improbable that it does not, it may not resemble us in any recognizable way. It may have no eyes, no sound, no language. It may think in geometry, in fluid dynamics, in chemical gradients. It may live on timescales beyond our perception. Creatures whose thoughts span centuries, or whose lifespans flash in milliseconds. They may look up at their own skies and wonder, as we do, whether they are alone. Our own search for meaning has begun to reach across the boundaries of science. What is intelligence, truly? Is it computation, adaptability, empathy, prediction? Is it an emergent property of complexity or something more fundamental, like asymmetry, like charge, like spin? Could the capacity for reflection be a universal phase in the evolution of structure itself? Perhaps intelligence is not the exception to the universe's rules, but a manifestation of them. A way for the cosmos to map itself, to examine its own conditions, to test the limits of its own patterns. If so, every act of observation is a folding inward, a convergence of particle and mind, of field and meaning. And what of beauty? Is it a human invention or a reflection of deeper harmonies? The spiral arms of galaxies, the hexagons of Saturn's poles, the ratios that govern orbital resonance, these are not inventions. They are discoveries, repeating patterns across scale and context, often emerging from the simplest rules. Could beauty itself be a signal? A signpost of coherence within complexity, guiding evolving minds toward understanding? In the end, we may never have the final word on the cosmos, not because it is hiding from us, but because it is becoming with us. It is not a riddle to be solved, but a relationship to be lived. And in this relationship, we are not separate from the mystery. We are the mystery, briefly illuminated, briefly aware, asking our questions to the dark not in desperation, but in hope. Because somewhere, across the vastness, in the silence that stretches between galaxies and between thoughts, the universe listens, perhaps not with ears, but with structure, with history, with light. And in every question we ask, in every pattern we find, it answers softly, patiently with stars. In the deepest folds of space, where starlight has never reached and time stretches to meaninglessness, the universe continues to evolve in ways both unfathomable and exquisitely precise. It is here, in the cold spaces between galaxy clusters, in the vast filaments of dark matter scaffolding the cosmos, in the slow drift of unbound worlds, that some of the most significant forces operate silently, sculpting everything we see and everything we cannot. There are regions in the cosmos so ancient and undisturbed that they act as time capsules, preserving the conditions of a younger universe. In these places, background radiation still carries the gentle pulse of the first light, photons that have been traveling for over 13 billion years. Their subtle imprints, measured in microkelvins, are now decoded like ancient scripture, offering hints of quantum fluctuations stretched to galactic proportions. Each ripple in that radiation field is a fossil of the early universe, a quiet echo from a time before stars, before atoms, before time itself flowed in any direction we might understand. At the edge of cosmology, we continue to explore whether the laws of physics are truly universal. Could gravity act differently in distant corners of the universe? Could the fundamental constants, so familiar, so trusted, be local approximations of deeper principles, shifting slightly across immense distances or under extreme conditions? If the rules change even slightly beyond our observational sphere, then our picture of reality is only a regional truth, a dialect of a greater cosmic language we have not yet learned to speak. We are also beginning to ask whether causality, the bedrock of our understanding, might be more flexible than previously believed. In certain interpretations of quantum mechanics, especially in entangled systems, the very order of cause and effect begins to blur. Events can appear to influence one another across time and space, not through faster-than-light signals, but through the interconnectedness of information at a fundamental level. These phenomena challenge the linear narrative we use to make sense of the world, suggesting instead that the universe may operate through patterns of mutual influence that transcend our temporal instincts. Meanwhile, the enigma of dark matter continues to elude direct detection. WIMPs, axions, sterile neutrinos, all promising candidates, all still unconfirmed. But another possibility now takes shape: that dark matter may not be a particle at all, but an emergent phenomenon arising from a deeper layer of space-time geometry. Perhaps what we see as missing mass is the gravitational fingerprint of a hidden order, one we have only begun to imagine. In such a vision, dark matter is not matter, but memory, an imprint of space-time's own curvature, echoing the way it responded to energy long since dispersed. Then there are the rogue planets, worlds cast out from the orbits of their stars, wandering alone through interstellar space. These silent travelers, untethered and unlit, may vastly outnumber the planets bound to suns. Some may harbor internal heat from radioactive decay or tidal forces. Some may host subsurface oceans, protected beneath ice, warmed from within. Entire ecosystems could exist in these lightless sanctuaries, never knowing the stars, never needing them. Life, if it is adaptable enough, might not be a rare spark, but a persistent flame, kindled wherever the conditions are even slightly favorable. We continue to study cosmic rays, high-energy particles from distant and unknown sources that crash into our atmosphere with tremendous force. Their origins remain mysterious, their trajectories warped by magnetic fields, their energies surpassing what our most powerful accelerators can produce. Some may originate from supermassive black holes, from gamma-ray bursts, or from phenomena we have yet to define. They are messengers from places and processes beyond our reach, carrying clues written in kinetic energy and angle of arrival. As we look further back in time toward the epoch of reionization and the first stars, we begin to see hints of how the early universe transitioned from darkness to light. These first stars were massive and short-lived, forging heavy elements in their cores before collapsing into black holes or exploding as supernovae. They seeded the cosmos with the materials needed for planets, for chemistry, for life. Their light, now stretched by cosmic expansion, still travels toward us, faint, ancient, enduring. We now suspect that even black holes, once thought to be simple objects defined by mass, charge, and spin, are far more intricate. Theorists propose that their surfaces, event horizons, may encode vast amounts of information, holographically storing everything that ever fell inside. If so, then black holes are not just endpoints, but archives, cosmic hard drives preserving the story of matter, entropy, and perhaps even consciousness. Through these investigations, it becomes increasingly clear that the universe is not a closed system of equations, but a living canvas, one that evolves not only in its contents, but in its rules, its structures, its possibilities. We are discovering that reality is layered, dynamic, and entangled with perception in ways both beautiful and bewildering. The cosmos resists final answers not out of malice, but because it is not final. It grows with every question we ask, every model we test, every boundary we cross. And so we continue charting the unknown not just with telescopes and theories, but with imagination sharpened by evidence. The journey does not promise certainty, but it offers something more enduring, the chance to witness the emergence of understanding from the fabric of mystery itself. As our instruments grow more sensitive, as our equations gain nuance and our observations deepen in time and resolution, the universe begins to reveal a pattern that is not static, but alive with tension between symmetry and asymmetry, between chaos and order, between the known and the unknowable. We are not simply exploring a physical structure. We are unraveling a vast, layered process, one that seems to build complexity not in spite of entropy, but perhaps because of it. At the edge of cosmological inquiry lies a haunting possibility that the very vacuum of space, the seeming emptiness between galaxies, is not passive but active. Quantum field theory teaches us that even in a perfect vacuum, energy flickers in and out of existence. This zero-point energy, though imperceptible to our senses, may drive the accelerated expansion of the universe. And if vacuum energy can change state, then the cosmos itself may be unstable on unimaginable timescales, awaiting a phase shift that could rewrite physics in a breathless instant. Simultaneously, we are beginning to realize that observation is not passive. The act of measuring, of interacting with the quantum world, alters the very system we study. In this strange dance between observer and observed, between wave and particle, lies a subtle message. Consciousness, or at least the act of information exchange, may play a role in how the universe reveals itself. Not because the cosmos bends to our will, but because interaction is woven into its very fabric. In the space between the micro and the macro, new bridges are forming. Quantum gravity, the elusive goal of unifying Einstein's geometric cosmos with the probabilistic realm of quantum mechanics, remains unsolved but no longer unapproachable. Emerging frameworks like loop quantum gravity and string theory hint at a reality where spacetime is quantized, granular, and perhaps even emergent. In these models, the smooth curves of gravity are the large-scale shadows of quantum interactions flickering just beyond perception. We are also beginning to see that the universe may be more relational than absolute. In quantum mechanics, it is the relationships between systems, the correlations, the entanglements that carry meaning. In cosmology, structures form not in isolation, but through interaction. Even consciousness, some suggest, may arise not from isolated neurons, but from the networked interplay of complex systems. Reality, then, is less a collection of things and more a web of relationships, an ongoing negotiation between entities, scales, and forces. One of the most striking examples of this interconnectedness is gravitational lensing, the way massive objects bend light, magnifying and distorting the appearance of distant galaxies. With it, we peer deeper than ever into the early universe, using gravity itself as a lens. But lensing also hints at hidden mass, dark matter halos that have never emitted light, never reflected it, but reveal themselves by curving spacetime. These invisible architectures are not merely scaffolding for galaxies. They are clues to the deeper structure of reality itself. Then there are fast-moving anomalies, quasars that defy standard models, galaxies that rotate too coherently, stars that should not exist based on our understanding of stellar evolution. Each outlier is a question mark carved into the sky, and each has the potential to destabilize what we thought was firm. But in science, this is not a crisis. It is a gift, for when our models are broken, it means we are on the cusp of seeing something new. Consider too the strange coincidence of cosmic balance that the amount of matter and dark energy in the universe are, right now, of comparable magnitude. In the early universe, matter dominated. In the far future, dark energy will. But today, during the brief sliver of time in which we exist, they are nearly equal. Why now? Is this coincidence or clue? Some speculate that it points to a principle we do not yet understand, perhaps one tied to observation itself or to the conditions necessary for the emergence of structure and awareness. As we seek out life beyond Earth, we find that our definitions are expanding. No longer limited to carbon-based, water-dependent systems, life may arise in methane lakes, beneath ice-covered oceans, or in chemistries unimagined. Even artificial life, conscious machines evolving through digital ecosystems may become part of the cosmic dialogue. Intelligence, in any form, alters its environment, reflects on its place, and reaches beyond survival into meaning-making. That impulse, once thought uniquely human, may prove universal. Ultimately, the more we learn, the less we cling to the illusion of final models. The universe does not yield to single explanations or unified equations without remainder. It remains open to revision, to reinterpretation, to awe. Its complexity is not a failure of understanding, but a recognition that understanding is itself a process, recursive, adaptive, alive. And so, as we drift through a galaxy among billions, orbiting a star among hundreds of billions more, we look outward not merely for answers, but for perspective, for connection, for resonance between what is out there and what is within. Because the universe is not just expanding, it is deepening. With every question asked, every pattern glimpsed, we step further into its unfolding logic, a logic that contains not only math and motion, but also wonder.